Hello students, welcome back to the discussion of the chapter Electrochemistry, and we are going to continue our discussion with respect to problems based on Faraday's laws. Okay, so let us consider one such numerical here. The question is, what current strength in ampere will be required to produce 2.369 into 10 raised to minus 3 kg of copper from copper sulfate solution in 1 hour? How many moles of electrons are required? That is another part of the question. Okay, molar mass of copper is 63.5 grams per mole. So let us quickly write the data which has been given to us. We have been given the mass of copper as 2.369 into 10 raised to minus 3 kg, isn't it? Time which is given to us is 1 hour, which we need to convert into seconds. That is 60 minutes multiplied by 60 seconds, which gives us the answer as 3600 seconds. Okay. Molar mass of copper is given as 63.5 grams per mole. Now students, here the weight of copper is given in terms of kg. So that's why we also convert this molar mass in terms of kg, so which gives us the value as 63.5 into 10 raised to minus 3 kg per mole. Okay, so this is the data which is given to us. What we are supposed to find here is the moles of electrons required and the current strength, right? Current strength in ampere has been asked to us. To find these two values, we have the formula here. So the very first formula here is for moles of electrons passed, and that formula is moles of electrons passed is nothing but moles of copper produced upon the mole ratio of copper. Okay, so that is one of the formula which we are going to use. Another formula to find the current strength, we have I, which is equal to Q by T, isn't it? So let us get into the discussion of the solution of this numerical. So we are going to use these two particular formulae, isn't it? So now here, if I want to find the moles of electrons passed, I need to have the values of moles of copper and mole ratio of copper, isn't it? So let us first of all find the moles of copper produced. So moles of copper produced is nothing but mass of copper upon molar mass of copper, right? So here we simply substitute the values as 2.369 into 10 raised to minus 3 upon 63.5 into 10 raised to minus 3. So on dividing, the answer comes out to be 0.0373 moles. So these are the moles of copper produced. Alright. Now we need to find the mole ratio, isn't it? Now to find the mole ratio, we need to have the half reaction for production of copper. So here the half reaction is Cu2 plus 2 electrons will give you Cu, isn't it? So if I want to find the mole ratio of copper, can I say here it is nothing but moles of copper produced in this half reaction upon number of moles of electrons required, isn't it? So in this half reaction, moles of copper produces 1, isn't it? And number of moles of electrons which are required are 2. So in short, here the mole ratio becomes 0.5. So now we have found both the values, that is moles of copper produced and also the mole ratio of copper. So we will be able to find the moles of electrons passed, isn't it, through this particular formula. So now we simply substitute the values of moles of copper and its mole ratio. So the values are 0.03730 upon 0.5, that is the mole ratio, isn't it? So here answer comes out to be 0.0746 moles of electrons. So these are the moles of electrons which are passed during the electrolysis of copper sulfate solution. Okay. Now let us get into the discussion of another part of this question, that is to find the current strength, isn't it? Now to find the current strength, we need to find the value of Q. And Q is nothing but moles of electrons passed multiplied by 96,500, because we need to find the answer in terms of coulombs, right? So the moles of electrons passed, just now we found it is 0.0746 multiplied by 96,500. So the answer here comes out to be 70 to 100.26 coulombs, precisely 70 to 100 coulombs. Okay, so now we have got the value of Q. So if you want to find the value of I, we have the formula Q upon T, right? So Q is nothing but 70 to 100.26 upon time is 3600 seconds. So precisely here the answer for current comes out to be 2 amperes, right? So that was the another part of the numerical to find the current strength. So I hope students you have got a clear idea with respect to this numerical. Thank you all. God bless you.